Hey, these are a couple of examples for non-special triangles. The process isn't very different from special right triangles, except we don't have the sides memorized, so we'll have to use Pythagorean theorem to find them. Other than that, the process is the same. Like this function, the inner function is what we'll evaluate first. Also notice this one is inverse function, so it should have restrictions, quadrant 1 and 4. But because the ratio is a positive value, so between quadrant 1 and 4, we'll stick to quadrant 1. Alright, here's our angle, complete a right triangle. This is 90 degrees, opposite over hypotenuse, which puts me into Pythagorean mode. Hence, 3 squared minus 1 squared is what will give me the leftover side. That's 9 minus 1, that's root 8, which is b. Again, root 8 can be simplified further. It's not a simplified radical, because it can be split into root 4 times root 2. That's a funny little square root sign. So root square root of 4 is 2, so 2 root 2 is the value of b, so this side is 2 root 2. First quadrant, so all sides are positive. And then all I have to do is find the tangent of that angle. Right? That's all I have to do, find the tangent of that angle, which is opposite over adjacent, that's 2 root 2. Let's quickly rationalize it. Times root 2, divided by root 2. The root 2 over 2 times root 2 times root 2 is 2. And 2 times root 2, 2 times 2 is 4. So there we go. That's it. This one is done. Example 2. Something similar. Okay, sine, cosine, inverse 2 over 7. Alright, inner function is inverse again, so we gotta follow cosine inverse restrictions, which is restricted to quadrant 1 and 2. However, cosine is positive, not in second quadrant, so we'll stick to quadrant 1. Here we go, here's our angle, finish it off. Adjacent over hypotenuse, let's find the missing one, which would be 7 squared minus 2 squared. That would give me the third side. That'll be 49 minus 4, fun. And b equals square root of 45. I mean, I feel tempted to not leave it like that, just because I know it can be simplified. Root 45 is root 9 times root 5, and root 9 is 3. So the simplified version of that radical is 3 root 5. 3 root 5. All I have to do is find sine of all of this setup. And sine is opposite over hypotenuse. Fun. This is my opposite, and that's the hypotenuse, and this is already simplified. We are done. Notice both the triangles were non-special. We just have to follow Pythagorean. Alrighty, see you in class.